Okay, so for all of you out there in the software world, especially those aiming for senior level interviews,
Okay.
I think this will be interesting. We're going to talk about a really interesting way to handle simple data.
Yeah.
Think about writing code that's not just functional,
Mm-hmm.
but also cleaner, more concise, less likely to throw those errors. That's the sweet spot we're aiming for.
For sure. And, as you're stepping into a senior role, you're expected to not only write good code,
Right.
but also design systems
Yeah.
with an eye towards long-term maintainability, efficiency. And
Exactly.
Okay.
Right. So how do you structure even basic data?
Right.
And that has a ripple effect across the entire code base.
Absolutely.
So consider those fundamental data structures that we use all the time. Coordinates ranges, simple configurations.
Yep.
Traditionally defining these involved writing a significant amount of repetitive code.
Yeah.
The class definition, private fields, the constructor, the getters, it can feel like overkill.
It is.
For something so simple.
Yeah.
And that's precisely where the language feature we're diving into today really shines.
Absolutely.
So our goal here is to give you a solid understanding of this tool,
Yep.
how it streamlines data representation, and why it's a valuable concept to grasp, especially as you prepare for those in-depth technical discussions that are part and parcel of senior level interviews.
Absolutely.
Okay, so let's unpack this.
Okay.
We're talking about records.
Yes.
At its core, a record is a specialized kind of class designed specifically for holding immutable data.
Right.
It's a more direct and less verbose way to define objects that are primarily about their data.
Exactly. Think about a simple point class with X and Y coordinates.
Okay.
In a traditional Java approach, you might write something like, and I know this will be a little hard to follow, but
Sure.
class point private final double X, private final double Y, public point double X double Y, public double get X, return X, public double get a Y, return a Y. At override public string to string, return point X plus Y plus potentially equals hash code, etc.
Right. So it works.
It works.
But it's a lot of code for something so simple.
A lot of code just to represent two doubles?
Yeah, just to hold two numbers.
Yeah.
Now let's contrast that with the record syntax.
Okay.
It's remarkably concise. Record point double X double Y.
That's it.
That's it. One line.
One line. And what's really fascinating here is the power packed into that single line.
Yeah.
The compiler does so much work for us.
Right.
It automatically handles the creation of private final instance variables named X and Y, a constructor that takes double X and double Y as arguments, and public accessor methods.
Yeah, but it's worth noting that the accessor methods aren't the traditional get X and get Y.
Right.
With records, they just use the name of the variable.
Exactly.
So X and Y.
It's a subtle difference, but it really contributes to that cleaner feel.
Right, so you would create a point instance like this.
Yeah.
For p new point 3, 4, and access the coordinates using double slope, px.
Absolutely. And this reduction in boilerplate isn't just about writing less code.
Right.
It has significant implications for maintainability, especially in larger projects.
Oh, sure.
When you have fewer lines of code, it's easier to read, understand, and refactor.
Yeah.
This becomes especially important when you're working in a team or revisiting code you wrote months ago.
Yeah.
Which, let's be honest, happens all the time.
All the time, yeah.
As senior engineers.
Yeah, for sure. Now, it's not just the basic structure that records give you for free.
No, it's not.
I recall there are other fundamental methods that are automatically generated.
Yes, indeed. Every record automatically gets sensible implementations for toString, equals, and hash code.
Yeah.
These are crucial for object representation and comparison.
Right.
Well, we could spend a whole episode talking about how these are generated.
Yeah, for sure.
The key takeaway is that records handle these common necessities for you.
Right.
Reducing the likelihood of bugs in these often overlooked methods.
Okay, so records offer a really clean way to hold basic data.
Yes.
But what if you need to add some specific behavior to these data structures?
Yeah.
Can records do more than just act as simple containers?
Absolutely. You can add your own methods to a record just as you would in a regular class.
Okay.
For instance, with our point record, we could easily add a method to calculate the distance from the origin.
Okay.
Point double X, double Y, public, double distance from origin, return math.hypo, XY.
Okay.
This demonstrates that records are perfectly capable of having associated behavior. They're not just passive data holders.
Right. So you get the inherent conciseness for data storage.
Yep.
But still retain the flexibility to encapsulate logic relevant to that data.
Exactly.
Now, I also saw caution mentioned regarding redefining those automatically provided methods.
Yeah.
What's the potential for problems there?
This is a crucial point about being deliberate when you override the default behavior of a record.
Yeah.
While the language allows you to provide your own implementations for methods like X or Y, as long as the signature is compatible,
Okay.
you need to be very careful.
Okay.
If you introduce an inconsistency, for example, having the X method return the Y value, like
Right.
this record point, double X, double Y, public double X, return Y, potential bug,
Yeah.
it can lead to very subtle and difficult to debug errors.
Right.
And during code reviews, this kind of deviation from the expected behavior should definitely raise a flag.
Yeah, that makes perfect sense. It's like the language provides a sensible default.
Right.
And if you deviate, you need to have a really good reason
Yeah,
and be extra vigilant about potential side effects.
absolutely.
Another restriction I noticed is that you can't declare instance variables directly within the body of a record.
Right.
What's the reasoning behind that?
That restriction is fundamental to the design philosophy of records.
Okay.
They are intended to be transparent data carriers, where the state is solely defined by the components declared in the record header. Allowing additional instance variables in the body would introduce state that isn't part of that primary definition,
Yeah.
blurring the lines and potentially undermining the simplicity and clarity that records aim to provide.
Got it. It keeps the focus squarely on the data that defines the record's inherent state.
Exactly.
Now, there was another caution around immutability.
Yes.
While the instance variables are final suggesting immutability,
Right.
it seems there's a nuance to be aware of.
Yes, this is critical, especially for senior engineers who should have a deep understanding of immutability and its benefits in software design.
Absolutely.
While the instance variables of a record are indeed automatically final,
Okay.
this only guarantees that the reference itself cannot be reassigned to a different object.
Right.
If a record's instance variable refers to a mutable object, like an array or a list,
Okay.
then the contents of that object can still be changed after the record instance is created.
Interesting.
For example, with record point, double chords, you could still do something like point pp equals a new point, new double 1, 2, 0, 0 equals 10.
Okay.
And the internal state of the point instance would have been modified.
Oh, wow. So the record itself isn't deeply immutable if it holds references to mutable types.
Exactly. This is often referred to as shallow immutability.
Yeah, that's a really important distinction to keep in mind,
It is.
particularly when you're designing systems where data integrity and predictability are paramount,
Right.
because this kind of unexpected mutation can be a source of really tricky bugs.
Absolutely. And, you know, immutability at the data structure level becomes so valuable in concurrent programming scenarios, preventing race conditions and making reasoning about the state of your application so much simpler.
Yeah, absolutely. A critical concern in complex systems.
Absolutely. And ones that senior engineers often design.
Right, exactly.
Mhm.
So if true deep immutability is a requirement for your record, then you must ensure that all the types of its components are themselves immutable.
Exactly.
This is a key design consideration.
It is.
That would likely be discussed in depth when talking about data modeling and concurrency in a senior level interview.
Absolutely.
So remember, records provide shallow immutability by default.
By default.
If you need deep immutability,
You got it.
you must ensure all contained types are also immutable.
That's right.
Okay, let's shift gears a little bit and talk about constructors.
Okay.
It seems like records offer a few different ways to handle initialization.
They do.
What's the difference between canonical, custom, and compact constructors?
So the canonical constructor is the standard one that's automatically generated for you.
Okay.
It takes all the components declared in the record's header as parameters
Okay.
and initializes the corresponding instance variables.
Got it.
This is the primary way you'll typically create instances of a record.
And when would you need to define custom constructors?
You might want to provide custom constructors to offer more convenient or alternative ways to instantiate a record.
Okay.
For example, you might want a constructor with fewer parameters that provides default values for the others.
Right.
Or perhaps a constructor that takes different types of arguments and performs some initial conversion.
Okay.
The key rule with custom constructors is that every custom constructor must ultimately delegate to another constructor of the same record.
Gotcha.
And eventually, this chain of delegation must lead to the invocation of the canonical constructor.
Right.
For our point record, you could have a record point
Okay.
double X double Y, public point this, 0.
Okay.
This provides a no-argument constructor that creates a point at the origin.
Right. That makes sense. It allows for more flexible object creation,
It does.
while still ensuring that the record state is properly initialized through the defined components.
Right.
Now, the compact constructor sounds particularly interesting.
Yeah,
It is.
That's something special.
The compact constructor provides a very concise syntax specifically for situations where you need to perform validation or normalization of the constructor parameters before they are assigned to the instance variables. You define it without explicitly listing any parameters.
Right. It implicitly uses the parameters declared in the record's header.
Gotcha.
The code you put within the compact constructors block is executed before the automatic assignment of the parameters to the instance variables happens.
Okay, could you give me a practical example of when a compact constructor would be really useful?
Certainly imagine a range record that represents a numerical range with a from and a to value.
Okay.
A common requirement might be to ensure that the from value is always less than or equal to the to value.
Right.
Using a compact constructor, you could enforce this. So record range, int from, int to public range, if from to, int to, from two ways, from 2 put to 2.
Okay.
In this case, if the provided from value is greater than the to value, the compact constructor swaps them before they are actually assigned to the from and to instance variables.
Okay.
This ensures that every range instance you create will always have a valid internal representation.
So it's a really elegant way to enforce invariance or pre-process the input parameters.
It is.
Right at the point of object creation, ensuring data consistency from the outset.
That's right.
And I noticed you mentioned that you can't directly access or modify the instance variables within the compact constructor's body.
Right.
Why is that?
That's because the compact constructor runs conceptually before the instance variables are initialized.
Okay.
Its sole purpose is to operate on the constructor parameters themselves.
Gotcha.
To validate them, normalize them, or perform any necessary checks.
Okay.
The actual assignment of these possibly modified parameter values to the final instance variables happens automatically after the compact constructor's code has been executed.
Okay, this deep dive into records has been incredibly valuable.
It has.
It's clear that they offer a significant advantage in terms of writing cleaner, more concise code for data-centric classes, which is a hallmark of efficient software development.
Absolutely.
It's expected of senior engineers.
That's right.
And understanding the nuances around immutability and the different types of constructors.
Yeah.
It seems like essential knowledge for anyone preparing for those senior-level technical interviews.
Absolutely. Being able to articulate the benefits of using records, understanding their limitations, and knowing how to leverage their features effectively demonstrates a strong grasp of modern language capabilities and a commitment to writing robust and maintainable code. All key attributes that interviewers look for.
In those senior candidates, so to summarize the key takeaways here, records provide us with conciseness.
Yes.
A significant reduction in boilerplate code.
Yep.
Automatic generation of fundamental methods like toString, equals, and hash code.
And
they're ideally suited for representing immutable data.
Absolutely.
However, we need to be aware of the distinction between shallow and deep immutability.
Right.
Especially when our records contain mutable types. And we have these 3 distinct types of constructors, canonical, custom, and compact, to handle various initialization needs and validation scenarios.
Exactly. And knowing when and how to apply each of these concepts effectively is what distinguishes a solid developer from someone ready to take on the responsibilities of a senior engineer.
This has been a fantastic discussion.
It has.
For all of you listening who are preparing for those senior-level technical interviews, we hope this deep dive into records has provided you with some really valuable insights.
For sure.
And concrete points to discuss and demonstrate in your coding.
Definitely showing that you're aware of and can intelligently discuss these kinds of modern language features, and the underlying design principles can really set you apart.
So as you continue your interview preparation and your ongoing work, consider this. How does the core principle of clearly defining data-centric structures apply to broader software design patterns you might encounter?
That's a good question.
Think about how you achieve similar levels of clarity and conciseness in different contexts beyond just simple data objects.
Yeah.
It's a really interesting area to explore further, and of course we encourage you to delve deeper into how records interact with other language features and the broader implications for your design choices. Thanks for joining us on this deep dive.
Thanks, everyone.